Close your eyes and listen. Listen to the sound of your own breathing, a gentle rhythm in the quiet of the room. Now imagine yourself looking up into a vast, clear night sky. The stars are not just points of light. They are destinations. They are ancient campfires telling stories older than time itself. For all of human history, we have watched this sky. We have seen the familiar dance of planets, the slow waltz of constellations. We thought we knew the neighborhood. But what if a traveler appeared? A visitor from a place so far away that its light took thousands or even millions of years to reach us. In this journey tonight, we are going to follow the trail of such a visitor, a mysterious object that passed through our solar system, leaving behind more questions than answers. It was named Oumuamua, and it has forced us to ask a profound question. Are we seeing the first evidence of technology from another civilization? Or are we witnessing a form of nature so strange it operates by a physics we do not yet understand? Let the questions fade for now. Let the story begin. Allow my voice to be your guide as we drift into the quiet, dark expanse where this mystery was born. Our story begins in a place of profound stillness, high above the clouds, on the dormant volcano of Haleakala, on the island of Maui. Here the air is thin and pure. The world below seems distant, a dream of oceans and green valleys. This is where the Pan-STARRS 1 telescope resides, a silent guardian. Its mission is to scan the heavens. It watches for the faintest flickers of movement, for rocks and ice that drift through the darkness between the planets. It is a sentinel, protecting our world from cosmic debris. On the night of October 19th, 2017, its digital eye caught something new, a faint speck of light moving with purpose against the static tapestry of stars. At first, it was just another designation in a vast catalog, a string of numbers and letters. An object named A/2017 U1. It appeared to be a simple asteroid, one of many thousands found each year. There was no fanfare, no sudden alarm. The discovery was routine, a product of automated systems and patient observation. But as the astronomers of the world turned their own telescopes toward this tiny visitor, a different story began to unfold. They traced its path backward in time. They plotted its journey through space, and they realized, with a growing sense of wonder, that this object was not from our family of planets. It had not been circling our sun for billions of years. Its path was a hyperbola, a clear, unambiguous arc that proved it came from the void, from the unfathomable depths between the stars. It was the first time in human history we had ever seen such a thing, a true interstellar visitor. The routine had been broken. The quiet of the cosmos was now filled with a thrilling new question. Who or what had come to call? As the realization dawned, the object needed a name. Something more poetic than a catalog number, something that captured the significance of this moment. The astronomers in Hawaii, who had made the initial discovery, reached into their native language. They chose a word that was both beautiful and deeply meaningful. Oumuamua. It translates to a scout from the distant past, arriving first. Picture this word in your mind. Oumuamua. It carries the weight of a long journey, the feeling of a message sent from an unknown shore. A scout. the first to arrive. This name itself framed the entire encounter. It was not just a rock, it was an emissary. It was a pioneer crossing the vast, empty ocean between solar systems to reach our island of light. The name invited us to imagine its origins. What star did it leave behind? What forgotten corner of the galaxy was its home? As we continue our own journey into relaxation, let this word echo gently in your thoughts. Oumuamua, a scout, a visitor, a whisper from a place we have never seen. The name was a perfect beginning to a story that would only grow stranger, more complex, and more profound with each new piece of information gathered by humanity's curious eyes. With a name secured, the scientific world scrambled to learn everything it could. Oumuamua was not lingering. It was already on its way out of our solar system, moving at an incredible speed. The window of observation was small and closing fast. Telescopes across the globe, and even the Hubble Space Telescope in orbit, swiveled to catch a glimpse. The first pieces of data painted a simple, if somewhat unusual, picture. The visitor was small, perhaps a few hundred meters long. It had a distinctly reddish hue. This color suggested a long exposure to the harsh radiation of interstellar space, a cosmic tan baked onto its surface over millions or even billions of years of travel. This red color is common on asteroids and other rocky bodies in our own outer solar system. So perhaps it was not so different after all. More importantly, it was inert. It seemed to be tumbling through the void. There were no signs of activity. No transmissions, no heat signatures, just a cold, silent piece of rock or metal passing through our home. It was a ghost ship sailing on the silent seas of gravity. The initial assessment was that we were looking at an interstellar asteroid, a piece of another solar system's building blocks cast out into the galaxy by some ancient gravitational disturbance. It was a fascinating, but ultimately understandable phenomenon, or so it seemed. The universe, however, had a surprise in store. The simplest observations often hide the deepest complexities, and this silent, reddish traveler was hiding a very big secret. The first hint of true strangeness came not from what Oumuamua was, but from how it behaved. As it tumbled through space, its brightness changed, and it changed dramatically. Over a period of about 8 hours, its brightness varied by a factor of 10. Imagine a distant lighthouse. You see its beam, bright and focused. Then, as it rotates, the light dims, almost to nothing, before flaring up again. This is what telescopes were seeing from Oumuamua. This rhythmic fluctuation, this cosmic pulse, could only mean one thing. The object had a very, very unusual shape. It was not a sphere. It was not a rough, potato-shaped asteroid like the ones we are used to. To account for such a massive swing in reflected sunlight, the object had to be extremely elongated. It had to be at least 10 times longer than it was wide. This data point shattered the image of a simple, boring rock. It was the first clue that our visitor was unlike anything we had ever encountered before. A flicker of light in the darkness, telling a story of radical geometry. Let your mind drift with this idea. A tiny object, tumbling end over end, flashing like a celestial beacon as it recedes from us. Each pulse of light is a piece of the puzzle, a question sent across the void. What are you? What shape do you take? the simple act of observing its light was transforming a discovery into a genuine enigma. The initial interpretation of this light curve data led to a stunning visual. The scientists concluded that Oumuamua must be shaped like a cigar, a long, thin needle of rock or metal hurtling through our solar system. Imagine that for a moment. Not a sphere, not a jagged rock, but a sleek, impossibly long object, hundreds of meters in length, but perhaps only tens of meters in diameter. This image captured the public imagination. It was futuristic. It was reminiscent of science fiction spacecraft. It felt unnatural. No known natural process in the universe creates objects shaped like this. Asteroids and comets are typically lumpy, irregular, or roughly spherical due to gravitational forces. A cosmic cigar was a statistical improbability of the highest order. The artist's impressions filled the news. A dark, reddish, cigar-shaped object set against the backdrop of our familiar sun and planets. It looked alien. It felt alien. This was the moment the conversation began to shift from a purely scientific curiosity to a topic of public wonder and speculation. Could this be a ship, a probe, a piece of derelict technology from a race of starfarers? The shape alone was enough to ignite these questions. It was a direct challenge to our assumptions about what the universe can create. As you relax, let this image form in your mind. A silent, dark cigar tumbling through the emptiness. A shape that does not belong. A form without precedent. It is a powerful, unsettling, and beautiful idea. While the cigar shape was a compelling and dramatic image, it came with its own set of physical problems. As physicists and astronomers studied the object's rotation, they realized that a cigar-shaped object tumbling in the way Oumuamua was would be highly unstable. It would be in a state of chaotic motion. Imagine throwing a pencil into the air with a spin. It doesn't just rotate smoothly on one axis. It wobbles and tumbles in a complex, unpredictable way. This is known as an excited rotational state. And for a long, thin object like a cigar, this tumbling motion would be very, very pronounced. While this fit the chaotic light curve data, it raised other questions. How could an object travel for millions of years through interstellar space in such an unstable state? Wouldn't it have settled into a more stable, simple rotation over such vast timescales? Some scientists argued that a collision in its recent past could have sent it tumbling, but there was no evidence of this. The cigar hypothesis, as elegant and sci-fi as it was, began to look less likely under the cold, hard lens of physics. The mystery needed a new shape, a new form that could explain the dramatic changes in brightness without defying the laws of motion. The universe was presenting a riddle, and our first answer was proving to be insufficient. The journey of understanding was just beginning. Each new piece of data did not clarify the picture, but instead added a new layer of complexity, a new veil of strangeness. So, if not a cigar, then what? The astronomers went back to the light curve data. The extreme variation in brightness was the key, 10 to 1. What other shape could produce such an effect? They found another possibility, one that was perhaps even more strange, even more unnatural seeming than the first. The object could be a disk, a pancake, something incredibly thin and flat. Imagine a coin or a dinner plate flipping through the air. When you see it edge on, it is just a thin line, reflecting very little light. But when its flat face turns toward you, it reflects a great deal of light. It becomes a bright circle. This model, a flat disc-like object, could also explain the 10-to-1 variation in brightness. It would be tumbling, presenting its thin edge and then its broad face to our telescopes, over and over again. This new shape was just as bizarre as the cigar, if not more so. What natural process could create a giant, flat, spinning piece of rock in the depths of space? The image is just as compelling. A cosmic discus, spinning on its journey out of our solar system. It feels less like a vessel and more like a piece of something, a fragment, a shingle from a cosmic roof, perhaps. This new model was more stable from a physics perspective than the cigar, but it did nothing to solve the problem of its origin. In fact, it may have deepened it. Whether a cigar or a pancake, Oumuamua was a geometric anomaly. It was a shape that whispered of strange, unknown processes, or perhaps of design. While the debate about its shape raged on, another team of astronomers focused on a different question. Was it a comet, or was it an asteroid? This is a fundamental classification in astronomy. Comets are dirty snowballs. They're made of rock, dust, and frozen gases. When a comet gets close to the sun, the heat causes these ices to sublimate, turning directly from a solid into a gas. This gas erupts from the surface, creating a beautiful, glowing atmosphere around the comet's nucleus. We call this atmosphere a coma, and the solar wind pushes this gas and dust away, forming the iconic cometary tail. An asteroid, on the other hand, is mostly rock and metal. It is dry. When it approaches the sun, it simply heats up. It does not form a coma or a tail. So the test was simple. Point the most sensitive telescopes at Oumuamua and look for the faint, fuzzy signature of a coma. Search for the presence of water vapor or carbon monoxide or any of the other gases that comets are known to emit. This would be the deciding factor. If a coma was detected, then Oumuamua was an interstellar comet, a weirdly shaped one, to be sure, but a comet nonetheless. The case would be, for the most part, closed. It would be a natural object easily explained by existing science. The search for a cometary coma was meticulous. Powerful instruments like the Spitzer Space Telescope, which detects infrared radiation, stared at Oumuamua, looking for the telltale signs of dust and gas. They were searching for the faintest whisper of activity. The results came back, and they were stunningly clear. There was nothing, absolutely nothing. No dust, no water vapor, no carbon dioxide. Oumuamua was completely inert. It was as dry and silent as a bone. This was a crucial piece of the puzzle. It was not a comet. The lack of a coma, despite its close pass by our sun, was definitive. It flew closer to our sun than the planet Mercury, a region where any ice should have been boiling off furiously. But there was only silence. This ruled out the most obvious explanation for an object coming from the cold depths of interstellar space. Out there, in the dark between the stars, ice is common, rock is less so. So an interstellar comet was expected. An interstellar asteroid was a surprise, but a weirdly shaped, dry-as-dust interstellar asteroid was a genuine shock. The mystery of Oumuamua deepened once more. It was defying our expectations at every turn. It was not following the script. It was writing its own, and we were struggling to read the language. The confirmed lack of outgassing seemed to settle the matter for a time. Oumuamua was therefore classified as an interstellar asteroid, the first of its kind, a traveler of rock and metal from an unknown star. This was still a monumental discovery. It was proof that the pieces of other solar systems could, and did, travel the galaxy and visit us. It opened up a new field of study. Imagine being able to analyze the geology of a planet orbiting another star, right here in our own backyard. But even as this consensus was forming, there was a nagging feeling that the story was incomplete. The shape was still a problem. The cigar or pancake form was so statistically unlikely for a natural object. Why would the very first interstellar visitor we see be the weirdest one imaginable? It's like walking into a forest for the first time, and the very first tree you see is perfectly square. You would immediately suspect something was amiss. Some astronomers were satisfied to simply classify it as an anomaly, a 1 in a trillion chance, a fluke of nature. But for others, this was not enough. They felt that to simply label it as weird was to give up on a deeper understanding. They kept watching. They kept analyzing the data. And they were about to find the biggest anomaly of all. An anomaly that would blow the case wide open and set the stage for the most extraordinary hypothesis of all. The final and most profound piece of the puzzle came from tracking Oumuamua's trajectory with extreme precision. As the object began to leave our solar system, astronomers noticed something that should not have been happening. Its path was deviating. It was not following the perfect, predictable curve dictated by the sun's gravity alone. Something was pushing it. It was a tiny push, a subtle, gentle acceleration away from the sun. But it was unmistakable. It was real. The object was speeding up ever so slightly as it departed. This phenomenon is called non-gravitational acceleration, and in astronomy, we have a very good explanation for it. It is what comets do. As a comet releases jets of gas and dust from its sun-facing side, it creates a tiny rocket effect. The escaping gas pushes the comet in the opposite direction. It is a form of natural propulsion. The problem was, we had already proven conclusively that Oumuamua was not a comet. It had no jets. It had no outgassing. It had no coma. So what was pushing it? What invisible force was giving this object a gentle nudge on its way out the door? This was the central, undeniable mystery. An object with the acceleration of a comet, but with the appearance of an asteroid. It was a contradiction, a paradox, gliding silently away from us into the dark. It was this final, inexplicable fact that would change the entire conversation and lead one prominent astronomer to propose an idea that was both brilliant and to many unthinkable. Let us take a moment to truly appreciate the subtlety of this final clue. The push was not a dramatic burst of speed. It was not the firing of a powerful engine. It was described as a gentle acceleration, a force that was 0.1% of the sun's gravitational pull on the object. Imagine a vast, calm lake, and you see a single leaf drifting across its surface. You expect it to be carried by the gentle current, but then you notice it is moving just a tiny bit faster than the water around it. Something else is acting upon it. a faint, imperceptible breeze perhaps. This is the scale of the mystery we are talking about. It was an effect so small it could only be detected by the most precise measurements, compiled over weeks of observation. But in the world of celestial mechanics, a world governed by the precise and unforgiving laws of gravity, this tiny deviation was a shout. It was a clear signal that our understanding was incomplete. There was a missing piece, a force unaccounted for. This gentle push became the focal point of the entire Oumuamua enigma. It could not be explained by gravity. It could not be explained by cometary outgassing. So, what was left? The answer to that question would depend entirely on how willing one was to entertain extraordinary possibilities. As you feel yourself drifting, feel that gentle push, a quiet, persistent force guiding you deeper into a state of rest. A force as mysterious and as gentle as the one that acted on our interstellar visitor. This is the point in our story where the narrative splits into two very different paths. The first path is the path of conventional science. It seeks an explanation, however unlikely, within the known laws of physics and nature. The second path is one of speculation. It dares to ask, what if this is not a natural object at all? The champion of this second path is a man named Avi Lôbom, a theoretical physicist and the former chair of Harvard's astronomy department. He is a respected and often provocative figure in the scientific community. He looked at the accumulated evidence, the extreme shape, whether cigar or pancake, the lack of a cometary tail, and most importantly, the slight but undeniable acceleration away from the sun. He considered the natural explanations being proposed, and he found them wanting. He believed they required too many special circumstances, too many unlikely coincidences. So he proposed a different idea, an idea that was both breathtakingly simple and profoundly shocking. He asked, what if the gentle push was not from gas escaping from within the object, but from a force being exerted upon its surface? What if Oumuamua was being pushed by sunlight itself? What if it was a solar sail, an artifact, a piece of technology from another civilization? The concept of a solar sail is not science fiction. It is real science. Humanity is already experimenting with this technology. The idea is elegant. Light, though it has no mass, has momentum. When photons, the particles of light, strike a surface, they impart a tiny, tiny push. Over a vast area and with a very lightweight object, this continuous stream of photons from a star can act like a wind, pushing a sail. A solar sail would need to be incredibly thin and have a large surface area, like a piece of cosmic tin foil, perhaps only a fraction of a millimeter thick. Now think back to the evidence for Oumuamua. The astronomers had concluded its shape was most likely a pancake or a disk, something extremely thin with a large surface area. Its acceleration was a gentle push directly away from the sun. This is exactly how a solar sail would behave. The pressure of sunlight would be the invisible engine, providing the non-gravitational acceleration. Avi Lôbom and his colleague showed that if you assumed Oumuamua was a solar sail, less than a millimeter thick, all of the observational data suddenly clicked into place. The shape, the acceleration, the lack of outgassing. It all made perfect sense. The pieces of the puzzle fit together to form a single, coherent picture. The picture of an artificial object deliberately designed to travel between the stars, propelled by the light of the stars themselves. Let this idea settle. An object designed and built by intelligent beings, drifting silently through our solar system. The hypothesis suggests that Oumuamua was not a random piece of rock. It was a piece of technology. It could be an active probe sent to scout our system. Or perhaps more likely, it was a piece of defunct technology, a piece of space debris from a civilization long gone. A ghost ship, its mission completed or aborted millions of years ago, now tumbling through the galaxy, a silent testament to its creators. It could be a buoy from a galactic navigation system, a shard from a massive alien structure. The possibilities are as vast as the imagination. This hypothesis, the solar sail hypothesis, addresses all of the bizarre characteristics of Oumuamua in one elegant stroke. It explains the pancake shape required for a sail. It explains the lack of gas, as it needs no fuel. And it perfectly explains the gentle push away from the sun. It is a solution that fits all the facts, but it comes at a price. The price is that we must accept the existence of other technological civilizations in the galaxy. For many, this price is too high. For others, it is the most logical and most exciting conclusion. The publication of Avi Lôbom's solar sail hypothesis sent shockwaves through the scientific community. The reaction was swift and largely negative. Many astronomers were deeply skeptical, and some were openly hostile to the idea. The common refrain was a cornerstone of scientific thinking, popularized by Carl Sagan. Extraordinary claims require extraordinary evidence. And while the evidence for Oumuamua's strange properties was solid, the evidence for it being an alien artifact was purely circumstantial. There was no radio signal. There was no direct image of the object showing metallic gleam or technological features. The entire case rested on the argument that all the natural explanations were insufficient. It was an argument from ignorance, they said. Just because we can't immediately think of a natural explanation doesn't mean one doesn't exist. To leap to the conclusion of aliens was seen as an unscientific, sensationalist move. The debate became heated. It played out in scientific journals, in the media, and in university hallways. It was a clash of two philosophical approaches to science. On one side, the conservative view, which holds that we must exhaust every possible natural explanation, no matter how exotic, before we consider an artificial one. On the other side, the view championed by Lôbom, which argues that we must be open to all possibilities, and that to dismiss the alien hypothesis out of hand is its own form of dogma. The burden of proof, of course, fell upon those who sought a natural explanation. If Oumuamua was not a solar sail, then what was it? The scientific community got to work, trying to devise a model of a natural object that could fit all the strange facts. The task was enormous. They needed to explain the extreme shape. They needed to explain the lack of a coma. And most critically, they needed to explain the non-gravitational acceleration, the gentle push. This became the great challenge of the Oumuamua story, a creative race to find a plausible, natural origin for this interstellar ghost. This is the beauty of the scientific process. A mystery presents itself, and the collective mind of humanity turns to solve it. Ideas are proposed, tested, and discarded. It is a slow, methodical, and often frustrating process, but it is our best tool for understanding the universe. As we drift and relax, let's appreciate this intellectual struggle, this passionate search for truth. It is a quiet, cosmic detective story played out in the language of mathematics and physics. A story that is still being written today. One of the most promising natural explanations to emerge was the nitrogen iceberg theory. This idea suggests that Oumuamua was not made of water ice, like a typical comet, but of frozen, solid nitrogen. Where would such an object come from? The theory proposes that it could be a fragment knocked off of a Pluto-like planet in another solar system. Planets like Pluto, in our own solar system, are known to have vast glaciers of frozen nitrogen on their surfaces. It is plausible that a giant impact could chip off a piece of this nitrogen ice and send it hurtling into interstellar space. This solves several problems at once. First, as this nitrogen iceberg approached our sun, the solid nitrogen would sublimate, turning into invisible nitrogen gas. Nitrogen gas would be very difficult for our telescopes to detect, which could explain why we saw no coma. Second, this slow, invisible outgassing of nitrogen would create the gentle rocket effect, explaining the mysterious acceleration. It was a clever and elegant solution. It provided a natural mechanism for the gentle push without a visible coma. It seemed, for a time, to be the perfect answer. A way to explain all the weirdness without resorting to aliens. The nitrogen iceberg became the leading natural explanation, a plausible life raft for scientists uncomfortable with the idea of a solar sail. However, the nitrogen iceberg theory was not without its own problems. As other scientists scrutinized the idea, they found some significant challenges. First, for such an object to survive a journey of millions of years through interstellar space, it would have to be quite large to begin with, as cosmic rays would slowly erode its surface. The calculated size and shape of Oumuamua pushed the limits of this. More importantly, the universe does not seem to produce many objects like this. Nitrogen ice is fragile. An impact large enough to chip off a piece would likely shatter it into tiny pieces, not create a single, large, pancake-shaped shard. Scientists calculated the odds. How many Pluto-like planets are there? How many giant impacts do they suffer? How many large, solid nitrogen fragments would be ejected into the galaxy? The numbers were not promising. The galaxy would have to be filled with an unbelievable quantity of these nitrogen icebergs for us to have a reasonable chance of seeing one. It seemed we had simply traded one unlikely object for another. Instead of a 1 in a trillion alien solar sail, we now had a 1 in a trillion natural nitrogen iceberg. The solution was, in its own way, just as extraordinary as the problem it was trying to solve. The mystery remained. The scales of plausibility were still delicately balanced between the natural and the artificial. With the nitrogen theory facing its own difficulties, other scientists proposed even more exotic natural ideas. One was the hydrogen iceberg theory. The idea is that in the coldest, densest parts of giant molecular clouds, where stars are born, solid hydrogen might be able to form. A chunk of this primordial, frozen hydrogen could have been ejected and sent on a journey to our solar system. Like the nitrogen theory, the sublimation of solid hydrogen into invisible hydrogen gas could explain the acceleration without a visible coma. The problem? No one is sure if solid hydrogen icebergs can even form naturally, let alone survive a journey of millions of years. It is a substance that is incredibly volatile. It is an idea on the very edge of theoretical physics. Another proposed solution was even stranger: the cosmic dust bunny theory. This suggests that Oumuamua was not a solid object at all, but an extremely light and fluffy aggregate of dust and ice, something with the density of cotton candy. Such an object would have a very large surface area for its tiny mass and could be pushed by solar radiation pressure, just like a solar sail. It would be a natural object mimicking an artificial one. But again, the question is, can the universe make such a thing? And can it hold together during a close pass by the sun? Each new natural explanation seemed to require a new, unproven type of cosmic object. It was beginning to feel like we were inventing new kinds of nature just to avoid the possibility of technology. And so, Oumuamua continued its journey. It crossed the orbit of Mars, then Jupiter, then Saturn. It grew fainter and fainter as it sped away from the sun and from us. In January of 2018, just a few months after its discovery, it became too faint to be seen by even our most powerful telescopes. It slipped back into the darkness from whence it came. It disappeared, but it did not leave a void. It left a legacy. It left a profound and unsettling mystery in its wake. We were left with its ghost, a set of data points, a light curve, a trajectory, and a collection of theories, each one more strange than the last. The object itself is now gone forever. We will never get a second look. We will never be able to send a probe to catch it. The chance for definitive proof, one way or the other, is lost to the void. All we have now is the story, the debate, the questions, and that is perhaps the greatest gift that Oumuamua gave us. It forced us to confront the limits of our knowledge. It forced us to imagine new possibilities. And it left us staring into the darkness, wondering what else might be out there, heading our way. This brings us to a third possibility, one that is perhaps the most profound of all. We have considered two options for Oumuamua. One, it was an artifact from an alien civilization, a solar sail. Two, it was a new and exotic but ultimately natural object, a nitrogen iceberg, or a hydrogen dust bunny. But what if there is a third door? What if Oumuamua was natural, but it was a product of a kind of physics that we do not yet understand? What if it is a messenger, not from another intelligence, but from another kind of reality? Our laws of physics are built upon what we can observe in our corner of the universe. We assume that these laws are universal, that they apply everywhere. But perhaps there are subtle variations. Perhaps in the cores of neutron stars, or in the hearts of distant galaxies, matter and energy behave in ways we cannot yet imagine. Oumuamua traveled for an immense amount of time from an unknown origin. Perhaps it was born in an environment so extreme, so different from our own, that it was forged into a shape and a substance that our current science cannot comprehend. This is not to say that it defies physics, but that it obeys a larger, more complete set of physical laws that we have only just begun to glimpse. Imagine for a moment that this is the case, that our visitor was not technology, but a piece of new nature. What could that mean? It could be a fragment of a collapsed star, a piece of a cosmic string, a naturally occurring object made of matter with properties we have only theorized about. Its strange, flat shape might not be designed for sailing on light, but might be the natural crystalline structure of a substance formed under immense pressure. Its gentle acceleration might not be from outgassing or light pressure, but from a subtle interaction with dark matter, or a leakage of energy from another dimension. These ideas are, of course, on the furthest fringes of theoretical physics. They are pure speculation. But in some ways, this possibility is even more awe-inspiring than the discovery of alien technology. The idea that the universe itself is fundamentally stranger, more varied and more creative than we have ever imagined. The idea that nature itself can produce wonders that we would mistake for magic or for artifice. Oumuamua could be our first clue that the cosmic rulebook is much longer and much more interesting than we thought. It may not be a message in a bottle from aliens, but a message from the universe itself. A message that simply says, "You know nothing yet." The legacy of Oumuamua is not just a single unresolved mystery. It has fundamentally changed the way we look at the sky. Before its arrival, the search for extraterrestrial intelligence, or SETI, was focused almost entirely on listening for radio signals. The assumption was that any contact would be a deliberate message, sent across the void for us to hear. But Oumuamua has opened up a new field, the search for alien artifacts, the idea that the evidence for other civilizations may not be a radio broadcast, but a physical object, drifting silently through our own solar system, a piece of space junk, a derelict probe, a functioning buoy. Avi Lёbom himself has started a new initiative, the Galileo Project, dedicated to this very search. Its goal is to build a network of telescopes specifically designed to scan the skies for objects like Oumuamua, and to be ready to analyze them in unprecedented detail if they appear. We are no longer just listening for whispers. We are now actively looking for footprints. We are searching the beach for driftwood from a distant, unknown shore. This is a profound shift in our search for our place in the cosmos. The story of Oumuamua is not a story with a neat conclusion, and that is what makes it so perfect for a journey into sleep. It is a story that invites contemplation, not certainty. It leaves room for wonder. It allows your mind to drift through possibilities without the harsh anchor of a final answer. We are left with a perfect balance of two extraordinary ideas. On one hand, the possibility that we were briefly visited by a piece of technology from another world, a silent, passing testament to another intelligence in this vast, lonely universe. The implications of this are staggering. It would mean that we are not alone, that the story of life and consciousness is not unique to this tiny blue planet. It would change everything about how we see ourselves, our history, and our future. It is a humbling and deeply hopeful thought. It connects us to a larger galactic story, a story that is still unfolding. Let that possibility wash over you. The idea of connection, of a shared cosmos, filled with other minds, other explorers, other dreamers. On the other hand, we have the second possibility, that Oumuamua was a natural object, but a natural object of a kind so strange, so new, that it challenges our very understanding of the universe. A nitrogen iceberg from a shattered exo-Pluto, a fluffy dust bunny born in the heart of a nebula, a fragment of a world with a different geology, a different chemistry, a different history, or perhaps even a hint of a new physics, a deeper set of rules that govern reality. This idea is, in its own way, just as profound as the first. It speaks to the infinite creativity of nature. It reminds us that the cosmos is not a static, predictable machine. It is a place of endless novelty and surprise. It means that even after centuries of looking, we have only scratched the surface of what is possible. There are wonders out there, natural wonders, that would seem to us like miracles. This possibility fills us with a sense of awe, a reverence for the deep, strange beauty of the physical world. Let that feeling of awe be your companion as you drift deeper. The feeling of standing at the edge of a great, unexplored wilderness. And so we have these two paths, the path of the artificial and the path of the natural, the solar sail and the nitrogen iceberg, the alien probe and the cosmic anomaly. Both possibilities are beautiful. Both are mind-expanding. And right now, tonight, you do not have to choose. You can hold both ideas in your mind at once. You can let them dance together. The mystery itself is the point. The question is the destination. For a brief moment in time, in 2017, the universe pulled back the curtain. Just a tiny bit. It showed us something that did not fit. Something that broke the rules. It gave us a riddle, and then it vanished back into the night. It was a gift, a reminder to stay curious, a reminder to keep looking up, a reminder that we live in a universe that is far more magical and mysterious than we can possibly comprehend. Oumuamua was a scout, a messenger, and its message was not a statement, but a question. A question that it left for us to ponder. A question that we can carry with us into our dreams. Since the passage of Oumuamua, our eyes have been opened. We now know that interstellar space is not empty. It is filled with travelers. And in 2019, we found another one. A comet, this time, named Borisov. It was in many ways the opposite of Oumuamua. It was a large, active comet with a bright, beautiful coma and a long, gaseous tail. It behaved exactly as a comet should. It was a textbook case. Borisov was, in a sense, a comforting discovery. It proved that our models of comets were correct. It showed us that normal interstellar objects do exist, and they look just like we expected them to. But the discovery of Borisov also served to make Oumuamua seem even stranger in comparison. If Borisov is the standard for an interstellar visitor, then what does that make our first guest? It highlights its uniqueness. It deepens the anomaly. It's like seeing 1,000 common sparrows, which only makes the single, brightly colored parrot that visited yesterday seem all the more remarkable. The normality of Borisov has only sharpened the mystery of Oumuamua. It has reinforced the idea that our first visitor was something truly, truly special, a statistical outlier of the highest degree. So where does that leave us as we drift here in the quiet darkness? It leaves us in a state of wonderful uncertainty. The debate about Oumuamua continues. New papers are published every year, proposing new theories or poking holes in old ones. There is no consensus. There is no final answer. And there may never be. The object is gone. The evidence is all we will ever have. And it is not enough. But this is not a failure. It is an opportunity. It is an invitation to wonder, to use our imagination, to contemplate the vastness of what we do not know. The story of Oumuamua is a modern myth. It is a scientific legend, a tale of a mysterious visitor from an unknown land who arrived unannounced, broke all the rules, and then vanished, leaving behind nothing but questions. It is a story that belongs to all of us. It is a reminder that the age of discovery is not over. The great explorations are not just in our past. They are happening right now every time a telescope opens its eye to the night. There are more mysteries out there waiting for us. More visitors on their way. And we will be watching. Let the story of this traveler be a soothing balm. It is a story about the universe, but it is also a story about us, about our curiosity, our desire to understand, our ability to be filled with awe. In our daily lives, we are often surrounded by things that are known, predictable, and certain. We crave answers. We want things to make sense. But the story of Oumuamua teaches us the beauty of the unknown, the peace that can be found in accepting that some questions may not have answers. It is okay to not know. It is okay to simply wonder. As you let go of the day, let go of the need for certainty. Allow your mind to be like deep space itself, vast, quiet, and open to all possibilities. Imagine the gentle tumbling of this distant object, the silent flash of its reflected light, the gentle, inexplicable push that guided it on its way. Let these images be your focus. Let them carry you away from the concerns of your world and into the grand, silent theater of the cosmos, a place of infinite beauty and infinite mystery. The name Oumuamua, a scout arriving from the distant past. Let's return to that name one last time. It implies a purpose. A scout is sent ahead to gather information, to see what lies beyond the horizon, whether it was a natural object or an artificial one. Oumuamua acted as a scout for us. It came from the great unknown of interstellar space and showed us that our solar system is not an island. We are connected to the rest of the galaxy. The space between the stars is not an empty void, but a vast ocean with currents and travelers crossing its expanse. It was the first we ever saw, and that changes everything. Before Oumuamua, the idea of interstellar objects was theoretical. Now it is a fact. We know that we are being visited, not with malice, not with intent, perhaps, but we are part of a larger, galactic ecosystem. Pieces of other worlds are drifting through our own backyard right now. This realization is a profound shift in perspective. It makes the universe feel a little less empty, a little more connected. Our little solar system is a port of call on a galactic ocean, and we are the lucky inhabitants, just beginning to notice the ships that pass in the night. So, as our journey comes to a close, we are left with this beautiful, unresolved chord. A story with two equally astonishing endings. Was it a piece of advanced technology? A solar sail from an alien civilization, tumbling silently through our system? A definitive, though quiet sign that we are not alone? Or was it a new kind of natural wonder, a nitrogen iceberg or a cosmic dust bunny, revealing that the universe itself is far stranger and more creative than we ever imagined? Either answer fundamentally changes our place in the cosmos. Both fill us with a sense of profound wonder. The truth is, we may never know for sure. Oumuamua is gone, receding into the darkness at tens of thousands of miles per hour, taking its secrets with it. But it left us with a priceless gift. It reminded us that the universe is under no obligation to make sense to us. It is vast, mysterious, and full of surprises. And that is a beautiful thing. Thank you for joining me on this journey tonight. I hope it has brought you a sense of peace and a little bit of cosmic perspective. If you've enjoyed this lecture for sleep, please consider liking this video and subscribing to the channel for more journeys into the quiet wonders of our universe. And now, for one final thought to carry you into your dreams, which story do you prefer? The story of the alien artifact or the story of the natural wonder? Let me know in the comments below. For now, just let the question hang in the air as you drift off into a deep and peaceful sleep. Good night.